The sine rule can be used to find a side or an angle when given the opposite side or angle and a pair of side and angle, while the cosine rule can be used to find a side or angle when given either two sides and an included angle or all three sides. The formulas and proofs are shown on screen.
In our first example, we need to recognize that the sine rule is required. From this, we must label our diagram and then state the sine rule. After stating the sine rule, we must sub in the known values. Because we're trying to find the value of x, we must get rid of the denominator of 8 by multiplying both sides by 8. From this, we simplify. Then after simplifying, we find the inverse sine of 8 sine 75 over 10, which will give us an answer, which we must round off to the nearest minute. So in this example, we are required to find the value of x. And first, we must recognize that the cosine rule is needed because we have an included angle between two sides. So first, we label the diagram and state the cosine rule. After doing this, we plug in the values according to the diagram, and then mainly after this is just an algebraic mess. So we resolve this issue by plugging in the squared numbers into the calculator. After doing this, we get a final answer of 93.599 recurring. Then we must take the root of this number and only include the positive value because we cannot have a negative side. For a harder example, this question is taken from the 2006 HSC. First, we must recognize the sine rule is needed, then label the diagram. After labeling the diagram, we must sub in the correct values into the sine rule. After subbing in the values, we must get rid of the denominator of 5, so we multiply both sides by 5. Now, in order to find theta, we must get the inverse of sine and plug in 5 sine 33 over 9. From this, we get a value of 17 degrees and 36 minutes, but because the question says nearest degree, we round it up to 18 degrees.
This is an HSC question from the 2011 HSC, and it's question 8a, uses the cosine rule. So the first thing we're going to have to do is identify that we need the cosine rule, and we know that because we're given two sides and an angle. So first thing we're going to do is state the cosine rule, and then substitute in the values given from the diagram. So we're putting those values in a, b, c, and cos a, with a being 60 degrees from the diagram. Then we're going to manipulate that algebraically until we get the equation given in the question. Because this is a show that question, we already essentially have the answer. We just need to know how to get it there. So as you can see, we're just manipulating it algebraically to get the desired answer of x squared minus 20x minus 84 equals to 0. So plugging that in and solving algebraically, we get that answer, and that's the end of that question. And we've proven it. And part B says that we need to use this to find the distance PL, so the nearest kilometre, which is the x kilometres. So here we've already started using the quadratic formula to find the 2 points of x. And this works because before we had a quadratic equation. So substituting these numbers into the quadratic formula that's been stated above, we're going to get two different solutions because of the plus or minus. And we're disregarding that negative solution because we can't have negative kilometres. So solving, we get x is equal to 24 kilometres. Our second topic in coordinate geometry. The midpoint is a middle point between two given points. The gradient is the slope of a line, and the distance is the distance in units between 2 points. All formulas and proofs are shown on screen and are available in our PDF notes.
So in this example, we are required to find the distance joining the interval a and b, and we are given the points of a and b. So we must recognize and label the x1, y1, x2, and y2 coordinates, and then state the distance formula. After stating the distance formula, it's a simple substitution of the x1, x2, y1, and y2 values. After this, we just simplify the third, and we get root 52, which can be simplified down to 2 root 13. This question requires us to find the gradient of AB using the same coordinates from the previous question. First, we label x1, y1, x2, and y2 and state the gradient formula. After stating the formula, it's a simple substitution with corresponding values to get a simplified answer of 3 over 2. This question requires us to find the midpoint of AB using the same coordinates. We label our x1, y1, x2, and y2 coordinates and state the midpoint formula. After stating the formula, we sum in our values and simplify to get a value for x of 3 and a value for y of 5.
This question asks us to find the distance when given 2 points. So we're going to substitute the points into the distance formula, and that'll give us an answer of the square root of 100, or 10 units for the distance of that line. For the question, we're asked to find the midpoint given the 2 points. So once again, we're going to substitute into the formula for midpoint. We're going to have a midpoint of 6, 8. This question is asking us to show that OB and AC are perpendicular. So we're going to find the gradients using the gradient formula and the points. The reason we're finding the gradients is that 2 lines are perpendicular if their gradients multiply to -1. So we're proving that they do, which proves that the lines are in fact perpendicular.
What have we learned today? Today we've learned about the sine and cosine rule, which can be used to find either the side or angle depending on the given information in the question. When referring back to the triangles in the proofs, we can derive which sides are for which values. We also learned about the midpoint, gradient, and distance formula, which are used to calculate the middle, the slope, or the distance of a given line with 2 specific points and the corresponding x and y values, which can be substituted into the formula. So that's all for today. We'll see you next week when we learn about the perpendicular distance formula.